Yusuf's already begging for the Zoom.
What?
Yusuf's already begging for the Zoom.
Such a goon. Goof at. All right. Beautiful. Great. Okay. Let's go ahead and start with anything you want to ask about from Tuesday night. So the 6 board problems I gave you from Tuesday night. Is there anything there that you would like me to go ahead and talk about? Hamza, I see your hands up over there.
Can you talk about the last two problems?
Talk about the last 2 problems? Sure. I could do that. All right. Woo! You're going to want to make sure you get your pictures. You want to make sure you get your questions taken care of today. I will not be here tomorrow. My wife has minor surgery I have to do with her tomorrow morning. Not major, minor surgery, so it's nothing to freak out over. But so I will not be here at all tomorrow. So that means you need to get your questions taken care of today. Okay, and the story. All right. So number 5, I gave you that the secant of theta is negative by thirds, and I also told you that the sine of theta is greater than 0. So to start off, that information allows you what quadrant come in. If I told you this, then right away you can tell me one of the other secant ratios. You know, cosine theta is what? How's cosine and secant? How are they related? Reciprocal. So you flip. So it's negative 3/5. Okay, great. Now, so what do I have? I've got a negative cosine and a positive sine. Cosine is negative. This is negative in quadrants 2 and 3. This is positive in quadrants 1 and 2. That means I am in quadrant 2. Okay? What you were supposed to do is what? Find the what? I want you to find the actual, you're supposed to solve for what? Theta? Okay? So let's think about this. We know, it doesn't have to be accurate, it's a sketch. I just need an angle and, here it is, there's theta. Okay? Do we know what these ordered pairs are? Do I have to? I don't have to know that. I do not have to know that. What do I know for sure? If I do this right here, do I know of these 3 values, what ones do I know? Do I know this? Come on, guys. Do I know this? Yeah, it's what? No. Look right there. It's what? I can say it's 1, but if I say it's 1, then guess what this is going to be? Cosine is either x over 1 or it's x over r. It's my choice. I could say that this is negative 3/5 over 1, or I could say that negative 3 is the x and 5 is the what? R value. That's my I can do it either way I want. I'll get the same answer in the end. So I'm just going to say that this is what? 3 and this is 5. So if I do inverse cosine, what am I going to get? I'm going to get the reference angle of theta. So literally, what do? I simply say the reference angle of theta is the inverse cosine of this. Why did I make it positive? Why did I not make it a negative 3/5? It won't make a difference, right? But why I did this because we defined the reference angle as an acute angle, and an acute angle is really a positive angle between 0 and 90 or 0 pi over 2. So that's why I ignore the negatives. Yesterday I told you just ignore the negatives because what you're doing is working with the right triangle. So if you do this, you get that the reference angle of theta is about, I think I wrote it down, about 0.927. So this angle right here is 0.927. That's the reference angle. 0.927. So how do I find theta? Theta then is pi minus that. Is that okay, Hamza?
Yeah, I never knew that we went over that cosine equals that cosine.
Well, yeah, we did that the other day. We did, it was the day, I think, was this the class where my computer shut down? I lost the thing or not? Yeah, it was that day we were doing it, I think. We talked about sine on the unit circle, and then to the right of it, I did it when the radius was r. What did we define them as?
Oh, because it's like opposite.
Yes! Hypotenuse is r.
That kind of stuff. Okay.
You remember that now?
Now I remember. Yeah,
Okay.
You made like a triangle, and then that's how you solved it. Okay.
Yep. Okay. So then you asked also for the last one, number 6. So number 6 was kind of similar in a way. I told you if the sine of beta is negative 0.68325, I want to find my angles, all angles. Okay, so first of all, what do I notice? The sign is negative. Where is the sign negative at? What quadrants? These two. Okay, so guess what that means? That means one angle is going to be, and I'm just sketching an angle in quadrant 3. I don't care where it is. It doesn't matter to me. This is one possibility of beta. The second one has to have a terminal side over here, and it has to be straight across from this one. Because their sine values, their y values, must be the exact same. So I know the other one then would be like this right here. So this is the other possibility of beta. Okay? Now what do I know? This is the reference angle. And this reference angle and this reference angle are going to be the exact same. How do I find the reference angle? The reference angle of beta is the inverse or arc sine of the positive of this. Because the sine of beta and the sine of this here are exactly the same. Okay, so now I find this. So if I do arc sine of 0.68325, I get about 0.752. So that's the reference angle. So this one, the red one, how would I find the red angle? It would be pi plus 0.752. How would I find the blue beta? It would be 2 pi minus. Oops. Pi 2.
Can you explain the arc sine part again? Like why you change it to positive?
Because I want this angle. This, if this is 0.68325, that's a y value. That's this. That's 1.
Oh, and then if you put it.
So I'm doing the sine, arc sine, to give me the angle there. And I don't do negatives because then it's going to put it in a different, I don't want that. Okay, it's all about what quadrant am I in, find the positive reference angle, and either add or subtract as necessary. So whenever I'm finding a reference angle, I am always going to do an inverse or an arc sine, any of them, of a positive value. You make it the positive to get the reference angle. Okay. All right. Does anybody else have a question on anything from the 5 board problems? So, real quick, when we're talking about the circle, right? And we know that up here it's x, y. Any point here is x, y. Any point over here is negative x, y. We know any point down here is negative x, negative y. Everything over here is x, negative y. And r is always positive. R is always greater than 0. Which ends up allowing us, and we know this then. We know this is to help those that. So we know that sine is y over r. We know cosine is x over r. We know tangent is y over x. I'm just concentrating on those. So what do I know? Anytime I'm in quadrant 1, all of these are what type of numbers? Positives. They're all good here. Over here, anything that has an x in it is going to be negative. Which one? Cosine and tangent. So the only one positive in quadrant 2 is sine. When I get to quadrant 3, what's happening? X and y are both negative. So this will be negative, but this will be positive. So tangent is. When I get to quadrant 4, what happens? Well, anything that has a y in it's negative. No, that's a negative, this is a positive. And then, of course, the reciprocals are true. Cosecant here, cotangent, and secant. All are positive. Sine's positive, tangent positive, cosine is positive. All students text constantly. All students talk constantly. All students take calculus. Okay? All kinds of things you can use to remember where they're positive at if you need to. Okay? All right. Anything else from the worksheet? Does that help you, Maddie? Is that what you were wondering about?
Yeah, but like when you have the fractions, how do you know what quadrant you're in?
Can you give me an example of what you mean?
Like you had negative 5 over 3 in the last
Okay,
one,
great.
right?
So, and it was and I gave you a trig ratio, you mean?
Yeah.
Okay, so if I did this to you, let's say I gave you tangent of theta equals, and I did this to you. I put it smack dab in the middle, okay? Right there, all you could tell me, if I said what quadrants it's in, you would say, well, I can't tell you exactly, but I know it's either in quadrant 2 or 4.
How do you know it's in 2 or 4 though? Like what do you look at the fractions?
Okay, because I know tangent is y over x, right? If I have a negative fraction, these signs, only one of them is negative. Where does that happen? Here, negative x and a positive y. Here, positive x and a negative y. Is that okay?
It's weird. I don't understand it.
It's okay. Okay, so let me do this. Here we go. Here's theta. What is true about this x value right here?
Negative.
It's a negative x. What about this?
Negative.
It's a negative value as well, right? It's a negative y. Okay, now, that means since tangent is defined as y over x, that's negative y over negative x, which is a positive. So that's why when I'm in quadrant 3, my tangent's positive. If I put it here, what happens? This is where my angle is. This is a negative x and a positive y. So the tangent of this angle is what? Y over negative x. It's a negative. If I put it down here, what happens? If I put my angle and it's down here like this, this has an x and a negative y. So if I did this one here, the tangent of alpha here, that's going to be what? Negative y over x. So I get negative tangent values when I have one of my coordinates is negative and the other one is positive. No. Okay. I'm trying to think what other way I can explain. Yeah, I'm not sure what
I just don't know how you're placing them. Like, I'm confused how you place what quadrant they're in still. Because, like, you said negative x and negative 3, but then you said there's positive quadrants. Like with the essay stuff.
Right.
Yeah.
And that's just talking about when you take the, like, so what all that thing I did in the previous page, this thing here, this is just saying if you take the sine of any angle in here, it's going to be positive. You take the cosine of any angle here, it's going to be positive. The tangent of any angle here is positive. Over here, sine is the only one that's positive because sine is defined as y over r. Well, what's true in quadrant 1 or quadrant 2? Y is positive and so is r. That's why the sine is positive there.
Yeah.
But if I do cosine, cosine is x over. So it's going to be a negative over a positive, which is a what?
Negative.
Yes. So that's why it ends up that the other ones are going to be negatives in this quadrant. I'm not sure where the gap is here to fix. I'm not sure where the disconnect is. Just think for a second. Okay, hold on. Savannah, maybe what you're going to say is going to help me help her. I don't know. When you say the previous page, you mean this one here or the other one? This one, okay. Not if tangent's negative. No, not if tangent's negative.
Yeah, that's what I mean. Like, how do you know where to put it if it's negative? If you put positives in the circle before? I don't know. I'm just confusing myself.
Wait, because if tangent's negative, I say to myself, where's tangent positive?
The fourth quadrant?
Tangent is made of y's and x's. It's y over x. It's defined as.
Yeah.
The only way you can have a fraction that is positive is that the numerator and denominator have the exact same sign.
Yeah.
Where does that happen? Quadrant 1, they're both positive. And in quadrant, they're both negative.
Yeah.
But what's a negative or a negative give me?
Positive.
That's why tangent is positive in quadrant 3. X is not positive, y is not positive. The tangent, though, of that angle to get there is positive.
So are you just kind of like looking where it would be positive if they were both negatives? Like if the 5 and the 3 were negatives?
So here, wait. Do you want me to stick with tangent or can I do a different one?
It doesn't matter.
Okay, here we go. Let's say I gave you this. All right? So you have to say to yourself, first of all, what is the sine ratio defined as on the circle?
X over R, I don't.
Not x over r,
Y.
y over r. Okay, r is always positive. So look at this. If I want this fraction to be negative, but I know r is always positive, then that means where's this negative really belong? Okay, so this is this. What does that mean? That means that I know that this angle has a radius of 5. The radius is 5. So this would be -5. This would be +5, right? If I went out. What is this y value? This would be at 5, and this would be at -5. What's this y value? -3. So that would be like this, right?
Mm-hmm.
That means that angle's somewhere over here. Is that right?
So that means it'd be in quadrant 3?
Yes.
Oh my goodness.
This one will be in quadrant 3, the way I have it written right now. Now, is there another place, though, where the y value is -3 and the radius is also +5? Yes, because this is -3. It could be here, but it also could be here. So this is one possibility. The other one would be that possibility.
Okay.
There's two different places it could be. I don't have enough information to say for sure it's in this quadrant. It's in one of these two.
So when it says like, so if you were to do a tangent, could you still use that same method you just used?
Yeah, it's the same idea.
So it doesn't really matter if it's sine, cosine, tangent?
No.
That's why I was getting messed up.
Yeah, because it's all the x's and y's change as I go from quadrants. Positives are since x and y are both positive here.
Well, so when you labeled the quadrants like sine, cosine, I thought that's where the coordinate had to be.
No, that's just telling
why
you
I was
that's where the
confused.
that's just telling you that ratio is positive
In those quadrants.
in that quadrants.
Okay, that clears it up.
Cool. All right. Savannah, do you still have a question? Okay. Anything else from the 6 board problems? Okay, let's talk about delta math real fast. And we're going to make this pretty quick, this delta math. So you're just going to, I'm going to go ahead and put it up here. And we're going to look at this. Hopefully it's still ready. So when I assign delta math, okay, I gave you 4 different pieces to look at, okay? So when I did it, I just looked at the titles of them and I chose them based upon that. I didn't really look at all the problems in there. So there was one section, and I'm not sure which one it was. I think it's the relationships, that there were a couple of them that you would not be able to do yet. And that's okay. So we're going to kick through this real fast. So this was the first section. It was the one on evaluating basic trig functions, okay? I believe all of these were quadrant 1 familiar angles, which meant that I'm asking you to know the unit circle. Why? Because the coordinates on the unit circle are the sine and cosine of the familiar angles on the unit circle. Because the sine is the y, the cosine is the x, right? That's all this is about. Do you understand that? So when I do sine of pi over 3, I just have to know, oh, pi over 3 has a y value of what? And that's all you had to do is type in. All you had to do here was type in then the square root of 3 over radical 3 over 2. Radical 3. And this one divided by 2. There it is. Submit it. Yes, that's what I want. Boom, it's happy. Yeah.
That would not, is it with a rational denominator? Would you accept a radical as a denominator?
Okay, so I said I would, and I said if you got something where they want to rationalize, you have to rationalize it. I mean, it's all about what the instructions say. If it's me and it doesn't state you must, then you don't have to. Here, in order to get it right, you had to.
Is that going to be on the quiz tomorrow, where we have to rationalize anything?
We'll talk about that when you get the gold sheet today. Okay, we'll talk about that. Okay, so all of these problems were like that. I mean, every single one here. Here's sine of pi over 6. Pi over 6, what's the y value? 1/2. So what's the sine of pi over 6? 1/2. Done. Here, tangent of pi over 3. All right, now this one, you got to think about for a second. Tangent of pi over 3. This is where you can start thinking of different. That's the same as the what? Sine of pi over 3 over the. Isn't that one of my identities? Sine over cosine is the same as tangent. What's the sine of pi over 3? But what is it? At pi over 3, what is the y value? So this is going to be radical 3 over 2 over, what's the cosine of pi over 3? What happens to the 2's? So what am I left with? Radical. That's all you had to do there. Everything here was in quadrant 1. Everything there was in quadrant 1. Okay? Cosine pi over 6. All right? Are we good with this first little unit? Yes. Okay, great. Here we go. Second one. Now it's not just in quadrant 1, and it's not just the 3 original trig ratios, it's all 6 of them. So cosecant of 11 pi over 6. What I could do in my head, when I see this, I'm thinking to myself, recip of what? Sine 11 pi over 6. That's what I need to be realizing. So what's the sine of 11 pi over 6? 11 pi over 6 is this bad boy right here. That's at what? Negative radical, I'm sorry, not negative. That's at radical 3 over 2, negative 1 half. So what's the sine? Radical 3 over, I'm sorry, negative 1. But I have to do what? So what's it going to be? Negative 2. That's all we're doing there. Okay? Thinking through, using our knowledge. Okay? This one, you wouldn't have to do that. This is kind of like the first unit. They gave you a nice one if they gave you this. Okay, let's do this one. If I see cosecant 5 pi over 3, it's the reciprocal of sine 5 pi over 3. What is the sine of 5 pi over 3? What's the sine of this? That's this guy right here. What's the y value? Negative radical 3 over. So then it's what? I have to flip it. So what I would want then is this. Now, I don't care about that. That's fine. Here you had to do what? Rationalize it. How do I rationalize that? Multiply it by radical 3 over radical 3. What you see down here is what you're going to multiply it by, guys. So I get negative 2 radical 3 over 3. That would be the final answer. For this, you have to do that. For me, that's good. They're equivalent. And like tomorrow's quiz, you could leave it like this and I'd be completely happy with it. So tomorrow you don't have to do that. You can leave it right here at this point. Do I need to do, you want me to do any more in this section here? We okay? All right. Next section you did. This is the one where when I opened it up, I did a couple examples like, oh, you guys could do this. Because I didn't check all the different possible problems. So this one you could do, right? I mean, hypotenuse over opposite is what? Which function is that defined as? It's cosecant. That's all they wanted you to do. Cosecant, boom. Why? Because this is the reciprocal of sine. SOHCAHTOA, CHOSHOKEO. It's your choice how you want to do that. Boom. Okay? This type right here, we have not done yet because I'm doing this when we do graphing in here. This will make more sense when we do the graphs of sine and cosine. So we didn't do this one yet, okay? So you didn't have to worry about this particular one. You couldn't do it. What's that?
I didn't even see it.
You didn't? Yeah, not everybody, you did.
I did. I just pressed sign.
Yeah, so if you didn't get one, you were fine. If you got one, you went, whoa, we didn't do it like that. And then I'm sorry, I didn't know it was in there. So don't worry about this. I'm not going to talk about it because I don't want to add that into the quiz tomorrow. So we're just going to skip, don't worry about those, okay? But this one, what about this? What is the cofunction of sine? So let's just see. I'm going to try cosine and see what happens. Yes! Sine and cosine are cofunctions. Okay? That means that secant and cosecant are. Okay, great. Let's keep going here. New problem. Oh, that's the same kind of a thing. Okay. What about this one? What do you think? I mean, it's a multiple choice. You can always guess. Sine and cosine. Cosecant and secant. Let's just see. It kind of sounds like they should be that. They do have co. Oh my goodness, the word co is in front of them. Wow. Okay. This is a good one. What's that? Sine. It's a reciprocal identity. Let's see if there's any more. What's that? Cosecant. What's the reciprocal of secant? Yeah, and I don't like exactly how this one's written, but what is the reciprocal function of secant? If you flip it, 1 over secant is what? Is the cosine, this guy here. Okay? That is the sine. No. Tangent. Those are, I thought they're just kind of like the fundamental trig identities we've been working on in here, okay? All right. Last section. Wait, did I go to the last section?
Yes.
I did, yeah, okay, good. Here we go. So, it says to simplify to a single trig function. What's cosine over cotangent? Oh, I don't know. I better use my basic identities to do this. This is the same as the cosine of theta over, how could I rewrite this? Let's write it like this. Does this mean cosine theta times 1 over cotangent theta? Is that true? Is that what that means? Cosine divided by, is it the same as cosine times 1 over?
Yes.
Sure it is. Okay, here we go. So that's cosine of theta times really the what? Tangent of theta. Because 1 over cotangent is tangent theta. Sure, I like that. That means it's cosine theta times sine theta over cosine theta. What are the cosine thetas going to do? What am I left with? That is not the only way of going through that. That's one possible way of thinking through that problem, though. Okay, that's a possibility. So that's what they were looking for you to do on this section here. So let's do another one of those. Let's do one that's not like that. This one's different. Okay, great. What is cosecant equal to? 1 over the sine of theta times the sine of theta over the, oh, cancel, cancel. 1 over cosine is what? Secant theta, boom, bam, slam, I'm done. Do we see how we're doing those?
Yeah.
So we're not solving, we're what? Changing appearance by using identities and trying to get down to one trig function. That's it. All we're doing now. Let's see if there, oh, let's do this one. This is a good one. I like this one. Here we go. All right. Couple ways of doing this one. Any thoughts? Yeah. Okay, so you're naming this sine squared theta over cosine squared theta. Love that idea. Times
1 over cosine squared.
1 over
Cosine. Or sine.
1 over sine squared theta. Love it. Those cancel. It's 1 over cosine squared theta, which is
Cosecant squared theta.
not cosecant.
Oh, secant.
Secant squared. So this is the answer. Secant squared theta. Boom. Anybody got a different way of doing that problem? Anybody give me a different way of doing that? Just curious. Any thoughts? Nobody has any? What's that? I'm going to make this 1 over cotangent squared. Is that what you're saying? Okay. When did we? What identities did I give you that had squares in them? The Pythagorean identities. Hey, check this. Watch this. I'm going to do it like this. I'm going to say tangent squared theta times, what is cosecant squared theta equal to? What's that? 1 plus cotangent squared theta. Wasn't that one of our trig identities?
Yeah.
Pythagorean identities? Were you here for that one, Maddie?
I don't think so.
Okay. Now what do I do? Is this right? Is cosecant squared theta? I gotta be careful here. Very, very careful. What does the identity say? It says that cosecant squared theta, right? Well, if you were with me, we said that what? This was, I think it was on, did we do this on Tuesday or we do it on Monday, the Pythagorean identities as extra ones? What day did we do those on? Tuesday? I thought it was Tuesday. You guys don't remember what it was? Maybe we did it on Monday and we reviewed it on Tuesday.
I remember you listing them on Tuesday, but I don't remember doing anything with them on Tuesday.
We had a 1 plus tangent squared theta, and we had a 1 plus cotangent squared theta. What was what? Plus tan was secant squared theta, and this was cosecant squared theta. So all I did is replace this with that idea. That's all I'm doing in my head. Is that okay to do that? But if I do this, I better get the exact same answer. Distribute this through. Something's not cool. What do I get? Tangent squared times 1 is going to be what? Now what's this going to give me? What if you take a function times its reciprocal? If you take a fraction times the reciprocal, what do you always get? 1. Right? You always get 1. Now I've got this. Oh, tangent squared theta plus 1 is what? Oh my goodness. Gave me the exact same answer. Crazy. Love it. Okay. 27. Okay, we're just not ready for a break. So this right here, I gave this to you because this is what you're going to need to be able to do in the future when we're solving and proving. Being able to rename, change appearance by using the fundamental identities. That's what's going on right here. Okay? That was great. I love that these square ones were in there because chance to use the old Pythagorean identities. So that was these. So I'm going to go real quick and give you today's stuff, and we can look through this. By the by, I'm going to just throw a question up here and ask it to you real fast. When you come back, we'll do that. I'll put these on your desk while you're gone. When you come back, we'll do these. We'll start. Get you guys going.
Can't go out.
It's snowing.
It's snowing.
It is not snowing.
It's
Oh
snowing.
my God. No. That is not okay. That is not okay at all. Snowing on April 1st, that's got to be an April Fool's joke there. Somebody's playing on us. That is not okay. Not okay that it's snowing outside. Oh, April Fools on the snow. Okay. You can only get one. One for Justin, but sorry.
I looked over this earlier.
We'll talk about this later when you come back. We'll talk about it.
Yep. Why?
I don't know.
Did you look at it online? Yeah, I don't know how to do any of this.
I don't either. Like, when he explains
Is
it,
it too
it
late
makes
to switch out?
sense.
Too late to switch classes?
I think
I mean, hell, we already earned 1 credit, right?
Yeah.
This is just like pathetic. Dude, like, who said that was okay? I'm about to move to the tropics, watching. Yeah, Florida. Cold bite. Go live on CSDQ Beach. Party in Miami on the weekends. If I were to go anywhere, I'd move to a lake. Have a nice lake house.
I went to Alaska.
What?
What?
You said you went there?
No, I would move. I could move anywhere I go.
That makes me feel stupid.
Me too. Every class makes me feel stupid.
Yeah. I literally was like, oh my gosh, I could go to take a nap. Nope, I don't work.
It puts the pressure.
Yeah, I gotta close.
Pretty bad.
It puts pressure in it.
I don't know how to do any of this,
Do
Savannah.
you know?
You're asking the wrong person. I'm telling you this right now. Like, love you with my whole heart, girl, but you have to know first.
I don't know what the zero means.
I don't know what any of this means.
What's
I learned about the algebra system.
No, it says like, I understand
Like
this.
I was
And then it confuses me when it says. Oh, it just means that cosine squared or cosine is less than zero, so it's negative.
What? How do you
Oh.
know that?
Because so anything less than zero is negative. So that
This is
means
just like so
that,
aggravating.
so because it's tangent, that means cosine has to be negative, and cosine is x, which means the quadrants have to be either
And this is our quiz tomorrow. I'm definitely failing.
2 and 3.
What
Has
else?
to be the quadrants. And then tan is negative, so I have to be 1.
Okay, can you explain to me how you're doing that? Because
Wait, why'd you? Okay, 4. Why is it 1? It's not 4. It's 2. Okay, but I just figure out why. Okay, so I don't listen to what people explain. I just remember that all of the identities are positive. Sine is positive. Tangent is greater than that, and then cosine is positive. It's this one. So if it's less than if cosine theta is less than 0, then it's negative. And cosine is positive here and here. So it narrows it down to these. And
Why does it narrow it down to those two? Because it's not negative, it's not positive.
yeah, because cosine is negative,
Okay.
but cosine is these two positive.
Okay.
And then tangent is negative.
How do you know tangent's negative?
Because there's a negative.
Okay.
And then it can't be this one.
So it could be 1, 2,
So it has to
3.
be 2. Because tangent's positive.
But like if you were to do your little pencil marks, you could put these two.
Yeah, because like, so you just find where they
But
overlap.
everything's positive here.
So it can't be there. It has to be there and there.
Okay, but quadrant 2, what does that have to do with anything?
Because both of them are.
I know, but like, what's the purpose of quadrants? Like, does it tell you more information on how to solve the problem?
It tells you whether you're adding or subtracting. And then it's like,
When we did the thing where like, I don't even know where my notes are for that.
okay, so
I lost my notes. I had a whole page full of them. They're gone. That's probably why I'm practicing tomorrow.
Now that we know that it would be pi minus blah 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 blah.
What? So this
What
is pi
what
minus?
does this have to do with it?
then cosine.
It's secant, right?
Oh, I don't know how to do this.
How do you find a
Alright,
reference angle?
I have no idea.
That's where you put whatever the thing is, and you do
Where
like
is it?
10, like either if it's like tangent, sine, or cosine, and then you make it like tangent. It's usually tangent. So you do tangent, -1, and then the fraction. And you put it in a calculator.
I hate this class.
What? Bruh,
I don't like this class.
I'm killing Sullivan for putting me in this. He's the reason I'm in here.
Really?
Yeah, she's like, you need to go take honors 2005 this time. You need to go do freshman year and sophomore year. Came to my geometry class and harassed me. So I said, you know what? I'll do it just for you. So now I'm gonna go sit and try to do
That was very menacing how you walked down the hole or the lockers.
Hey, Yusef, check this out.
Are you gonna, what are you about to turn on?
What do you mean?
Yep.
Look at that, Yusef! Woo! Thrill cam! Woo! Oh, Yusef, check it out! Wow!
Oh my god.
Whoa, Yusef, check that out! Woo! Woo! All right. Having fun. You got it. You got to grow old, but you don't have to grow up.
So on the other side,
Girl, you don't know about Raiders.
and then you put in the fraction. So
I don't know how you did it.
great question that I realized I'm stuck on.
What's that?
So, so when it's like tangent equals 10/17 and the cosine is less than 0, after you figure out what quadrant it's in, how would you fill out the rest of
I'm lost on the first question.
I know, that's why, and I was just getting ready to talk about it before going.
Is y.
Okay,
n is
so
y.
real quick, I want to talk about the very first question. So look, guys, up on the board, I have drawn an angle. Okay. Would you agree that that angle I gave you is like not a bad angle for what I've drawn up there? It's not a bad drawing. Why? Because I know when I get to here, it's how far? Pi, right? Okay. Which we know is about 3.14, so yep, that's correct. Now, here's what I want to know. There's theta. If I asked you to come up and draw the reference angle for theta, where would I draw it at?
Isn't it like right to the arrow, right to the arrow?
Yeah, it's between, what is this? This is
X
the
and
what?
Y.
But what do we call this part? Think about what this is, guys. This is the what? Negative x axis. So I would draw from the negative x-axis to the terminal side. Thank you. Boom. It's this. This is the reference angle right here. How would I find the reference angle? Now think. What do I know? I know that theta, theta is equal to pi, here's pi, plus the what? Reference angle. So how would I find the reference angle then? Solve this. How would I solve this? If I gave you this, 5 equals x, or back up. 5 equals 2 plus x. If I gave you this, how, not what, how do you solve that? You subtract 2 from both sides. What do I do here? Subtract pi from both sides. It's all. No different. Yes? You okay with that? You just slapped your head.
Yeah.
You're okay with that. So my reference angle here would be what? Theta minus pi. Boom, got an answer, I'm done. That's all you're doing. Huh?
Yeah, it says equals.
It says double minus because I'm so upset.
I told you.
There it is, okay? That's what number 1 and 2 are. That's all they're asking you to do.
So you're not writing an actual number?
Well, if you wrote it like this, I'd be happy. I mean, like on number 1, basically this is like, do you understand what quadrant you're in, and could you tell me what the reference angle is? So on number 1, what quadrant is 2.1 radians in?
2.
How do you know it's in quadrant 2, Hamza?
Yeah, how do you
Because so the negative x-axis all the way to the left, that is pi,
Which is about 3.14, yep.
and then the positive y-axis is pi over 2.
Which is a little, which is about half of this. What's half of 3? 1.5. Where's my number 2.1 at? It's between 1.5 and 3, so it's in quadrant 2. All I did was took the fractions and turned them into decimals in my head. That's
I
it.
think the radians is what gets me all shriveled up.
You got it, ooh, yeah. Okay?
I'm telling you, it's the radians.
So, guys, what I'd like you to do right now, 1 and 2 you should be able to get done, and then I'm going to put the answers to 1 and 2 up here in like 1 minute, because they're both the same style of problem. Okay, so I'm going to give you the answers to 1 and 2 in a second. Minute, my bad.
So I have a question.
Yep.
So I lost my note paper when we went over the circle thing where either add pi, subtract pi, stuff like that.
Uh-huh.
Can you go over that?
So,
Like what quadrant you would do what with?
well, let me put a new page up here, actually. Right. If my angle is in quadrant 1, here's theta. The reference angle of theta
Isn't it just the
is
same
the
thing?
same.
Yeah.
That's what I wrote. Okay. If I'm in quadrant 2, and this is theta, right?
Oh.
This is the reference angle, right?
Yeah.
This is the reference angle. So theta is pi minus the reference angle. Because these have to add up to how much? These two have to add up to what? Pi. Okay, so if these two have, if theta plus reference equals pi, then theta is pi minus reference. That's all it is. Is that okay? Yeah, you sure?
No.
You're not?
No, this whole unit is just
Look,
confusing.
If two numbers add up to, if I have two numbers,
No,
if I
I
told you
get
5
that.
plus 3 is 8,
Yeah.
then 8 minus either one of those is the other one.
Yeah.
That's all you're doing here. These two add up to that. So if I need to know one of these, you just subtract from pi. That's if I'm in quadrant 2. If I get to quadrant 3, here it is. Here's this time, what's true? Theta is pi plus the reference angle. Because I have to go past pi. Here, I'm short of pi. I don't make it all the way. I have to go from pi backwards. That's why it's pi minus. Here, I want to go past pi, so I have to go to pi and then add some more to it. And then the last one down there.
8 pi over 5 is 5 pi.
Say what? Like this? Unless you're told otherwise, yes. Okay? Then here, on this one,
Divided by 2.
this is the reference angle. So I have to go backwards from 2 pi, so it's 2 pi minus. Is that okay, Abby?
Yeah, I just have to look at it because I was writing it down.
Okay.
It is 8.
All right, so I'm going to go ahead and answer 1 and 2 up here. Okay? So number 1 would be the reference angle for this would be pi minus 2.1. Okay? Number 2, 8 pi over 5. This is in quadrant number 4. Okay? This angle is in quadrant number 4. Okay? That means that it's, what do I know? The angle plus reference equals 2 pi. So this is going to be what? The reference angle here is going to be 2 pi minus 8 pi over. You could leave it like that. If I asked you to simplify it, you should be able to. It's 2 pi over 5 if you simplify it. All right. How did I know that that was in quadrant 4? Any ideas? Yeah.
So I just kind of like calculated all of the like sides and decimals,
Yep.
and 2 pi is approximately 6.28, and then 3 pi over 2 is approximately 4.7. So it's in between.
Okay. All right, so here we go. Watch. This is how I did this one. Since it's in terms of pi, this 8 pi over 5, I just thought of it as 8/5 pi. All I have to do is compare the number 8/5 to these and know where it's at. 8/5 is the same as 1 and what? Okay, what do I have to know? This is the same as 1 and 1/2. That is 1.6. This is 1.5. Has to be in here. Has to be. This is coming back to mental math from like a long time ago, I'm using. You don't like that. What I just did, do you?
Me?
Yeah.
I don't like any of it. No, if I'm being completely honest, this is like stressing me
Okay.
right now.
What? You can be honest. I'm not going to be hurt by that.
Man. After you hit us with that unit circle, my brain just does not want to work.
Oh boy. Oh boy.
Oh.
Okay, so now try 3 and 4. Those are kind of more like last night. I gave you one like that. Okay, last night I gave you problems like, I guess it was number 5. 5 and 6, or number 6, I guess it was like that. Yeah.
I'm sorry.
No, you're fine.
So for quadrant one, for this, right, you said there's no change, because.
Quadrant 1 and its reference angle are the exact same. Yes. How is that?
Well, now I'm just do this. I forgot the definition.
Oh.
I'm not really sure.
Thank you.
Oh, yeah. Well, it's just that, but arc instead of the I don't think it. I don't really. Wait, actually, why is there arc and then why is there like the -1?
They're
Like,
the same thing.
Why are they the same thing? Like,
Because
why is it?
Raising to the -1 is the inverse of a function. It's going to be opposite direction. So,
It's just like another way to do.
right. So, well, because it's an inverse. Because if I give you the theta, if I give you the angle, you can give me the tangent. That's the function. The inverse will go the opposite direction. I give you the tangent and you give me the angle. Okay? But it's also referred to as the arc tangent. It's like what arc has a tangent of this amount, because the measure of the arc in degrees is the same as the central angle. That's why it's called an arc tangent as well. Two different things mean the exact same.
Where's that? So we have a new member.
Remember, I think I have no idea what I'm doing.
Me neither.
Y'all say that, but you got stuff on your paper. You see mine?
I'm gonna write down this one. You guys can.
So I just figured out the quadrant that was in.
How do you know what quadrant is? That's where I'm stuck. These quadrant things. How do you know that?
Because that's where the cosine is positive. The cosine is a positive number. So it has to be quadrant 1 or 4. Has to be.
Okay, so if it's quadrant 1 or 4, and theta is less than 2 pi, does it have to be quadrant 3 then? Because it can't be quadrant 4.
Well, I don't know what this is.
Oh, why don't we go out?
That's quadrant 4.
I just blocked that out, to be honest.
Okay.
Block it out.
At least
I just
1,000.
blocked
Let's
it
say the 3 decimal places. What'd you do? 2?
Values, so I just blocked it out.
That's fine. And look, you'll know if it's right or not, right? If I go to 1,000 and you didn't,
And then.
you'll know if you're right or not, because mine, you can just round mine and see if it's right. Okay? Don't worry about it. This is not for an accuracy grade.
We know that.
Tomorrow's quiz will tell you what's around you.
We know that cosine is positive, so we know that this is positive.
What if you get to the 2?
1 and 4.
I got
Yeah.
0.48.
Cause I don't pay attention. I don't know what that is.
5.8.
So that should be what we need to know. That's too funny.
I think that's what we need to know to figure out the other stuff.
For the other quadrant? I mean,
Because we know it's 1 or 4, but how do we determine X and Y?
No, you just list both of them. Because it says find two values. So you just list both of them.
What two values?
Like for this quadrant, because for quadrant 1, you're not like doing anything because the reference angle is just like defined by itself. But for quadrant 4, you're subtracting 2 pi to find theta.
So then you would literally just write theta for one of them?
I just wrote, well, you gotta find the inverse of cosine.
Why do you find the
Or
inverse?
I don't know.
So when would the answers be?
I just remember the process and try to duplicate it.
And then like 2 pi cosine.
You said 2 pi minus the cosine of theta?
Minus
This?
Wouldn't the answers just be this?
minus the inverse of cosine. So cosine to the negative first power. Because it's like the inverse. Like not like inverse as in like the unit symbol.
Oh my goodness.
Am I?
No, this, no. I just don't know why I can't grasp any of this.
I understand how. And then after that,
I don't know.
I can figure out what quadrant it's in, and then after that, I don't know.
Let's
what to
just
do with
skip
the
these.
information.
'Cause I have no idea. So let's just skip them. Let's go to 5.
I don't know how to do that.
So we know that sine is negative.
So first I do is write that, and then I go.
Okay, let me do what you're doing real quick. Let me try to figure this out real quick.
So
Okay, so
I don't even pay attention to this. I pay attention. Okay, cosine. Wow, it's less than 0. So it's
cosine.
negative.
It's not
Or
cosine.
cotangent.
I'm not saying
I'm
what are you
stupid.
talking about. I'm not
So
stupid, Abby. It's okay.
So we know cotangent is negative. So it can't be in
1.
3 or 1. It
It
has
could
to
be a
be
2 and 4.
Yeah. So I just make little marks. And then we go back to sine. Sine is negative. So sine
Can't be
It can't
negative and 4.
so it can't be
3 or 4.
quadrant. So it has to be 4.
Oh.
Mine
Which means
is
it's
my
quadrant.
understanding. Or at least take up speed.
So we know that it's in quadrant 4.
Right. And then what do you do with that information?
Yeah, that's what I'm stuck at.
I understand how to find quadrant.
Because it tells you like because then you take so since it's a quadrant 4, you take 2 pi minus whatever the inverse of these lines is. So I don't know.
I'm sorry, repeat that?
I'm being stupid.
No.
Everyone's learning process is different.
You're doing better than we are.
No.
So, obviously you're doing
At
better
least
than
you got
we
stuff
are.
on your paper.
I don't know.
I don't want to hear that.
Okay, so, we know it's quadrant 4.
Is this right?
Got rid of 3.
We know it's quadrant 4.
I guess
So,
change.
you would do 2 pi minus.
Wait, perfect. My calculator said one.
So then wait, what do you call this? Cosine to negative. That's not inverse, is it?
Yeah, that's inverse cosine or arc cosine, either
Okay,
one.
arc.
And you were when you did this, you were finding
The reference.
referencing.
Oh,
Okay.
no, it's
Okay.
You did,
So
yeah,
that's
you
why.
found the reference angle.
Okay. So that's why you need to know what quadrant it's in, because then you know whether or not to do anything with it, or you're not to subtract pi, add pi, or subtract pi.
And then you just do
And then
the,
this is the.
so you just do like
Maddie,
2 pi minus
Maddie,
whatever
here.
that angle, whatever that is.
Here, Maddie.
Hold on.
Okay.
I know.
So this is right. Is that correct? Or do I still have to find like the tangent?
You have to find the.
I want to find this angle right here, okay?
Gotcha.
Let's just say
Reference
this
angle,
first
that's
one.
the reference angle. So
So I'm gonna tell you that
you
this
just
is out
type in on
3,
Desmos cosine
negative.
-1, and then this number in the parentheses, and then it's
So either way, you have to
I'm
find.
going to draw a right triangle,
Whatever that equals in 2 pi minus.
because we always know in a right
Yeah,
triangle.
well, it depends
these
on
are
which
perpendicular
quadrant
to X's and
it
the Y's.
Yeah.
So
So
I'm
like,
just gonna ignore the negatives, because on a triangle, sides are always positive.
I don't want to write.
This would be 3,
Actually helps.
this would be 7, Okay?
I still feel stupid.
Now, I want you to think about this. This red angle from here to here and this little piece here together have to add up to 360 degrees, which is the same as saying they have to add up to radians. What I'm going to use is I'm going to do right triangle. I'm going to use trigonometry to find this angle here, which I'm going to call a reference angle. So this reference angle, if I'm using the legs, it's the tangent on a right triangle. So the tangent of the reference angle is equal to 7 over 3. First thing is notice that that's y over x. Okay? So the reference angle then is the inverse tangent. That's how you do this.
27.4.
Okay? So if I
Because
do
it's like
this,
the same when you said when you divide by 200, but instead it's the inverse of 35.
yes,
Like
not
1 is still 1 over 2.
yeah, there's two different meanings. This
Oh.
can mean this,
Ah.
if we're talking about it as a this, but it also can mean it's the inverse of the function like this. Those are inverse. That's another way of writing the inverse of the function. So that's what this is here. So I get this. I do on my calculator. I'm going to do second tangent of 7 divided by 3,
Wait, that's.
and I get that this angle is 1.17.
I thought you split it.
That's this reference angle. That's not theta. What do I know though? Theta plus the reference angle have to equal 2 pi. If I want theta, then theta is 2 pi minus the reference angle. Because I have to subtract this from both sides to get theta by itself.
And then you would plug in 1.7.
Yes, that's what you have to think through on this. Okay? So on that problem that she was just doing, where it gave you, on this one here where it said that the cosine of theta was 0.887465.
Yeah.
Cosine is x over r. That's what it's defined as. Think back to quadrant 1. If I'm in quadrant 1 and I draw an angle here like this, here's x, here's y, here's the radius, that's theta. Cosine is adjacent
Oh,
over,
wait, I didn't put it in.
so that's why cosine is x over r.
So I did get that.
Okay, now, this is telling me then, think of it like this. This is over what? 1.
Wait, I
So
got,
basically, x is 0.887465, and this is 1.
did you get it?
How do I find this angle here then? How do you find the angle of a right triangle if you know the two sides? You do the inverse cosine. You don't invert it, you do the inverse of cosine. You're going to go the opposite direction to find the angle with this. So theta, on this one, we're going to do the reference, it is theta on this one. Theta equals the inverse cosine of 0.887465. And if you do that, you get this, 0.479. Okay? Now that's this angle in quadrant 1. Where else is x positive? Well, it's right here. So the other possibility would be right down here. That the terminal side, instead of being here, this has the exact same x value right below it.
Yeah.
So the other possibility then is the angle that goes from here all the way to here.
Wait, no.
These two triangles are they're congruent. They're the exact same. So if this angle is 0.479, then this angle is That's why the second possibility, this guy here, is 2 pi minus it.
So now.
Is it getting any better at all when you get in? Not at all.
I don't think I've memorized everything. I
Okay.
promise I'm not crying.
That's okay.
But
Okay, so here's what you're gonna do. Go back and try number 5. See if you can do number 5.
okay.
Right? So I'm gonna put some answers up here for you guys so you know how you're doing on these. Oh God. So number 3, theta is about 0.479, and theta is about 2 pi minus 0.479. Okay,
Okay.
so you can that's number 3. Number 4, theta is either pi plus 0.106 or 10, I think it's 4. Is it 104?
We got 5.
5. I can't even read my writing. And then it's either pi plus 0.105 or 2 pi minus 0.105. The reference angle there was 0.105. Yeah.
Does the quadrant number 5 like have to do with the problem? Like which
Well, yeah, because the cosine, cosecant, secant, tangent, cotangent are all going to have signs based upon what quadrant it's in. And so is the angle. So look at what I've given you there. What are the two things you know about this? The sign is what? What kind of a number?
Negative.
It's negative. Where is the sign? So the sign's positive here and here.
Right.
So I know it's either quadrant 3 or quadrant 4. Then I look at this one and it says the cotangent is positive. Cotangent is positive, so is the tangent. Where is the tangent positive? Quadrants 1 and quadrant 3. That means I have to be in quadrant number 3. If I'm in quadrant 3, what do I know then? Both x and y are negative, and r is always positive. Always, always. So what do I know then? Cosine's going to be negative. Cosecant's negative. Secant's negative. That's going to be positive. That's going to be positive. This is going to be what kind of an angle? Bigger than 2 pi. As a matter of fact, when I find my angle, I'm going to take pi and add the reference angle to it because I know I'm in quadrant 3, and that's how you find those angles. I know my angle. You understand how I got to this part here?
Yes.
Abby, do you understand that?
Yeah.
So if I just draw any angle I want there, I don't care what angle it is. If I'm going to find that, it's pi plus the reference angle, which is right there.
Yeah.
So I know I'm going to have to do that again.
So you just use sine negative 12 over 13 to find the
Not negative. We always make them positive. And that will give me the reference angle, and then I'm going to add it to.
So then you would just change
So it is the
the
same
sign of it. So instead of doing sine negative 1, you'll do cosine negative 1?
Oh my God. You mean inverse?
Yes.
No, I would do inverse sine of 12/13. This value I want positive.
Okay, so then
Find the reference angle.
when you do A, you do inverse cosine.
No, stop. If this is a fraction, these should be fractions. You need to find, what is sine of theta defined as? It's y over
X. I mean R.
r.
Sorry.
That means that this is the y value and this is the r value. Think of it that way to find x if you want. You can do it that way if you want. What's wrong?
I understand. Like, I don't know. Is it so? Because I found the reference angle, but I'm just not.
Okay, what did you get for the reference angle to start?
1.176.
Okay, so now if I'm in quadrant 3,
Plus pi plus.
pi plus that.
But where do I put that? Like, is
That's
it?
theta.
Oh, that's theta.
That's the angle.
Okay.
How do you find anything of like other than cosecant and then theta without?
All right. So if you're struggling on number 5, guys, a couple things you can do. On number 5, I could think that this sine of theta is y over r, and this is my y value, and that's my r value, and then use x squared plus y squared equals r squared. Guys, there's a lot of stuff going on here. On a circle centered at the origin, what's true? X squared plus y squared equals r squared. Why? Because of the Pythagorean theorem. Sine of theta equals y over r. We define it that way. So look what I have. This has to be negative 12. Because the radius is always what? Positive. So I know y equals negative 12 and r equals 13. Plug them into this and find x. Then you can write any of the trig functions you want.
Okay.
Now, that's one way of doing it. The other way is to say to yourself, Gee, I know this is true also. Sine squared theta plus cosine squared theta equals what?
One.
1. 1. Square this. That's so all you would do is this. Solve for cosine squared theta.
And then we find cosine.
That's why it's called a Pythagorean identity. It's the Pythagorean theorem using the trig ratios.
When we're doing that, we always use the Pythagorean.
Can? Yes. No, it doesn't. It's so cool. I love, there's so many ways to do things. I love that. You guys want one way and only one way. That's boring in life. I love going, if I'm going somewhere, I go different routes every single time because it's more enjoyable. That's what I like here. I got different ways to do these.
But if you went faster one way than the other way, then wouldn't you go that way?
This is like
What's that?
If you
Yeah,
went faster
you're
one
right.
way.
But who know? I don't know which one of these is faster.
No,
No, I'm just saying in general. Like
You're
you're
stuck
stuck
on
on
the
Because
first problem.
right now you're held up in rush hour traffic, Maddie.
Oh,
you're flying an
What do
airplane.
we need this for? Like in life?
I might as well drop
Periodic
this here and
functions.
put a zero on it tomorrow.
But like, what do we use that for?
This is exactly what my-
Things that happen over and over and over again periodically. Periodic functions. Remember that problem I did with the Ferris wheel?
Exactly.
Yeah.
There are a lot of things that can be modeled periodically.
But will
For
we ever need to
cosmology, I'm
actually?
gonna need another.
I
set of
can't see
circles.
into the future, so I don't know.
Did you just hear me?
What?
Wait,
For cosmetology, I'm gonna need to know the unit circle and the radians.
Maybe.
No.
Yeah, because who knows? Maybe you're gonna do a professor's hair. They're gonna be talking about it. You're gonna show that you understand it. And they're gonna give you a bigger tip because of
I'm
that.
gonna change the topic. I'm gonna be like, listen, my
Oh,
math
then they're
teacher
gonna
tried
think you're
teaching
rude and
me.
you want to just focus on yourself and not them. And that's not you. When you do, when you have a client in front of you, you focus on their needs and their desires.
So if you
Therefore,
were
your
to
tip is
sit,
gonna be a
if you
zilcho.
were to sit in my chair and ask that unit circle, you would give me a zero.
I can take anything you tell me and I'll twist it against you. Trust me.
I know you can't.
I just did. I just twisted it
Here,
against you.
this is my quiz for tomorrow.
I put the grading now.
Yeah, you might as well.
So guys,
Like, that was tough.
listen up, guys. Later on today, you'll want to check online. I will put all the answers on there, and what I'll actually do is I'll kind of go back in here and redo it nicer and neat, and you can see it, what I did. Okay, and you can hopefully follow along on it. Now, I didn't tell you this yet, but I'll tell you now. I'm not going to be here tomorrow. I did tell you guys that? I didn't think I told you guys that yet. Oh, well then, no worries. Good. Just don't, you can't get me help from me tomorrow. That's what I'm saying.
Yeah, I know.
Okay, cool.
But I'm trying to get help now and it just doesn't work.
Maybe they're gonna be like, hey, I want you
What?
to cut my hair at 5 over
What?
3 on the unit. I won't.
What number are
I'll be happy. I don't have to take it.
What do you mean it's the
But if I
4.3?
stay up all night to study and we don't have.
I'm really confused about this though.
According-
This
did
is
you
what
do
I'm
art
not
something?
understanding.
And that's at finding an angle.
It's gonna, it is going to do. I know
It
it
is. It is.
And my grades are 71 right now.
I realize that everything we're saying you should hear.
A what?
Can we just do the code? Can you just like?
You wanna know how bad this is? Don't talk about I couldn't even identify the trigger identity is not science. With the opposite of all that, no, I can't use
Are you supposed to be nervous? Wait, it's too much.
We always do that. We always start like that. I just set it there.
Can I just like? Oh no, 'cause they gave me like. Never mind.
What's the problem here?
I don't know.
Why are you doing the cosine of that angle?
I was just thinking
Oh, I finally
Okay, like-
understand.
Wait, you do?
Oh, I got it.
Just do the sine of
Okay,
this.
so
Do the sine of this. This is going to be rounded. Do the sine of 4.318.
I understand. I understand.
Okay. Why are you messing things up?
Because that's what I am. I'm a mistake.
No.
I figured it out. So you already know the y, and you have to find the r. and R is technically speaking like X when you're solving. So now that you have X, and you have X and
Now,
Y.
do this. Take negative 12 divided by 13, and it better be very close to that number right there. If you rounded it otherwise. Look how close they are. Yeah. Hello.
Yeah, but like I just don't know how to like plug in.
Because you're not, you don't want to use this to get the answer. You want to use your knowledge of this. Did you ever find, what this is Y. Did you ever find X?
No.
You need to. X squared plus Y squared equals R squared. That's how you're going to write the remaining ones.
Do you need help?
No.
I need I'm here.
I need a blue white one. I just like this. That's my no idea. They even know what's
You think I would get those?
They don't have any right now.
Okay. Everything. That means that's a good time.
I got X.
That's how my head feels right
What is it?
5.
Now, what quadrant are you in?
3.
So it's really a negative
-5.
5,
Okay.
correct?
Yes.
Yes, so now you can write the other functions, right? Because what? Sine is y over r, cosine is x over r, tangent is y over x. That's why we have all those things that we know.
Oh, so we already knew like half of the problems from the beginning.
I know.
Oh. Okay.
Sine.
Why?
1 over sine. Sine is 12.
No way.
Yeah, way.
No way.
No way. Oh, way.
I know. No, I think I need a nap.
That sounds
Nice.
fun.
Cosine is X. I'm just lost on where to start.
Is this?
Is this going on our third quarter grade?
Now,
Great.
just so you don't know, I don't want you to stress out where you are. I'll be back Monday, Tuesday.
I know, and he's like,
Grades are not due until Wednesday.
yeah. I know.
You're like totally bummed. I mean, like,
I know I am.
really, really bummed.
Master.
You gotta give me your best.
Before he'll even let me
Because here's the thing, if you give me your best
I
on this,
literally have to master driving.
Maddie, if you give me your best on
I have
this,
to be able
I'll
to
look
drive
at
with
it.
people. I have to be able to
I'll look at it,
so I
and then on Monday, I'll help, I'll try to fix where you're weak, okay? You gotta do everything you can.
Got it. Oh, you need it. Mr. Sheriff, can you believe that?
What?
Alright,
My
I gotta
dad
put this
said
chair
that
back.
I have to have complete mastery over driving the boat before he'll even let me in one of our cars.
What?
He said he wants to see how I can make decisions.
That's a good idea.
But
You
don't
can't-
get me wrong.
It's a lot harder to hurt
drive
somebody out there in the
boat,
boat if you're in the middle of the lake.
The only thing he said I don't need to know how to do is dock. Because I can't.
These?
Yeah.
Oh,
I will
I'm
break
just right there.
Oh, okay.
I tried to get my certification for boating. That did not work.
I did. It took like a week. No.
Oh, it takes
I
like
didn't
that.
have a license. They even give you a little card.
Yeah, man, it's
Yeah. I have. And I usually look at my wallet.
Voting or?
Voting.
Okay, that's fine.
Cosine said I have to have complete mastery.
Yeah, well, what's right?
We've got.
The cosine and secant are both
Well, that makes sense because they're the reciprocal of each other, right?
Oh, boy.
Because cosine is, it's not, but everything else is X
You
over.
don't know anything, you don't take the time for things to click.
You're the worst kid.
Be a pirate.
Finally.
Okay.
Oh my gosh.
Oh my.
Yeah, I know.
So like, you need to tell them, do you know how they're divided on the circle? No. Then that's what we need. So here's what we're gonna do. Mark. If you say you can say, what was he like in another school? So right bias.
Yeah.
So Monday, you get our T5, 2 o'clock.
Yeah, I
Go
don't,
here for like,
I don't, yeah.
Hi, Maddie.
Depends on what time I have to go to work.
or Tuesday,
I don't work.
Tuesday. See you guys, Wednesday, I need to do some grades with you. Maybe you'll just do it online or do it some other way if we need to, but I'll help you. I'm not gonna let you falter,
I know.
okay? But I need you, whatever tomorrow, don't freak out because remember, you're gonna get a second chance. So do everything you can tomorrow. If you have questions on it, write down, I don't know, like, give me your honest best effort on there and write me notes on there so I know where I need to work with you, okay? Cool, all right.
I'm gonna take 2 tissues.
You go for it, take as many as you want.
All right, thanks.
See you, Maddie.
Why is it snowing?
Because it's April. Everybody knows it snows in April. I mean, that's exactly what I would expect, wouldn't you?
No.
Oh,